Trigonometry II. The figure below represents a plot of land ABCD, where BC is equals to CD, which is equals to 60 meters. Angle BCD is equals to 120 degrees. Angle ABC is equals to 75 degrees. And angle ADC is equals to 85 degrees. A. Calculate the distance from B to D through A. B. The plot is to be fenced using poles that are 3 meters apart, except at corner A, where the two poles next to the corner are each less than 3 meters from A. Calculate the distance from the pole at corner A to each of the poles next to it. Now, to calculate distance BD through A, we first have to calculate the distance AB and AD. Now, to be able to calculate AB and AD, we need to calculate BD first, because at least the information here is complete. Now, BD is gotten by getting 60 meters sine 120 over sine 30 degrees, and that distance is 103.923 meters. Now, having gotten that distance, we are now able to calculate AB. AB is gotten by getting 103.923 meters sine 55 over sine 80, which is equals to 86.4420 meters. Now, AD is gotten by taking 103.9230 meters sine 45 all over sine 80, and we get it to be 74.6183 meters. Now we add BAAD. If we add the two, it is 86.442 plus 74.6183. So the distance of BD through A is 161.0603 meters. Now, having done that, let's look at part B. Part B asks us the pole at A to its nearby pole. You realize that the poles at B, C, 60 is divisible by 3, so the distance is uniform. The pole at CD, 60 is also divisible by 3, so the interval is uniform. But the poles at A, B, and AD, the last one will not have uniform distance from the others, because the 86.4 meters and 74.6 meters are not wholly divisible by 3. So we shall divide by 3 and get the remainder. That remainder is the distance of poles nearby A. Now let's look at AB. AB 86.4420 meters divided by 3, we shall have uniform interval of 28, and then we shall remain with 2.442, which is not divisible by 3. That is the distance of the pole on the side of B to the nearest pole at point A. Now, let's look at AD. AD, 74.618 divided by 3. We get that we shall have uniform intervals of 24 and a remainder of 2.6183, which is not divisible by 3. That is the distance of a pole at A on the side AD to to its nearest pole. Now a hillside in the form of a plane inclined at an angle of 30 degrees to the horizontal. A straight section of the road, 8 meters long, lies along the line of the greatest slope from a point A to a point B further up the hillside. If a vehicle moves from A to B, what vertical height does it rise? Now, I have sketched that diagram. You can see AB and you can see B to S1. So B to S1 is the distance the vehicle will rise if it moves from point A to B. Now we know that point we have been given as 800 meters, and we have been given an angle of 30. This means that S1 and A and S1A and AB, they form an angle of 30. So you can use the sine rule to calculate the distance the car moves from A to B. That is sine 30 is equals to the opposite side over the hypotenuse. So AB becomes the hypotenuse, the opposite side becomes the hypotenuse is 800, that is AB. The opposite side BS1 is the distance the car will ascend when it moves from point A to B. Now, sine 30 is equals to BS1 over 800. Computing, you get that the height the car will rise is 400 meters. Now, part B, have been asked, D is another point on the hillside and it's on the same height as B, which means S2 and D is also 800 meters. Now, another straight road joins point A to D and makes an angle of 60 with the AB. C is a point on AD such that AC is 3/4 of AD. Calculate 1. The length of the road from A to C. Now we have been given an angle of 60 between AB and AD. That angle will help us to calculate the distance CB. Sorry, the distance AC. Now AD, we know AD, we can use the cosine rule because that is adjacent side all over the hypotenuse. So cos 60 that is the adjacent side. Adjacent side is AB is 820 meters. The hypotenuse should be AD. Now let's compute AD. What do we get? We get AD is 1,600 meters, but AC is 3/4 of 1,600 meters. So taking 3/4 of that, we get that AC is 1,200 meters. Now part 2 of part B has asked us to calculate the distance CB. The distance CB. The distance CB, you can use the cosine rule where it says that if you square CB and square the other sides, ACAB minus 2ACAB cos 60, they are equal. So CB is equals to AC squared plus, CB squared is equals to AC squared plus AB squared minus 2AC times AB times cos 60. But now to get CB, we shall have to take the square root of AC squared plus AB squared minus 2AC times AB cos 60. Now equating the value there, you get the CB is 1058.30 meters. Now, part 3, you have been asked the angle of elevation from B from C. Now we know the distance B to S1 is 800 meters. Now at C, the distance from C to the ground, what is it? That's the first thing you have to calculate. And to be able to do that, we have to know the angle of elevation of D from point A. That we calculate that by taking sine theta, which is the opposite side of the hypotenuse. We know the distance AD to S1 is 400. We have computed and gotten that AD is 1,600. So dividing that, we get that sine theta is 0.25, which translates to 14.4775 degrees from mathematical tables or using a scientific calculator. Now, what will be the height of C to the ground? We have now had the angle of elevation from D to A is 14.4775, which is the same angle of elevation from A to C. So you can use that to calculate the distance from C to the ground. So we use the sine rule, and we get the distance from C to the ground is 300 meters. Now it means the distance of vertical distance between B and C is 100 meters. Now, so it means from 100 meters, when you are standing from C, what is the angle of elevation to B? So we shall that we shall use sine theta, because we have the vertical ground 100, and we have the distance from B to C as 1058.3 meters. Now that is the opposite side and the hypotenuse. Dividing, we get that the sine is 0.0945, which translates to 5.4 degrees. So the angle of elevation of B from C is 5.4 degrees. A tower is on bearing 0.30 from a point P and a distance of 100 meters. From P, the angle of elevation of the tower, of the top of the tower, is 15 degrees, and the angle of depression of the foot of the tower is 1 degree. Find the height of the tower. Now, one thing we should know is that the angle of elevation and the angle of depression are the same. When you are down looking up, it is an angle of elevation. When you are up looking down, it's an angle of depression. Because when you are up on a vertical ground, and also when you are down on a vertical ground, the angle you are looking at, that line you are using to look at something, becomes a transverse between two parallel lines. So the angle of elevation and the angle of depression are two opposite angles made by a transverse to two parallel lines, so they are equal. This means the height of the tower, we shall take, let's say the top of the tower is PT. We shall take tan PT 15 degrees, and still also take tan PT 1 degrees. So we are calculating the distance from the top where the angle of elevation is 15, and also the distance from the bottom where the angle of elevation is 1. When you add the two, you get the height of the tower, which is 28.54 meters. Now, part B1 has been asked to, has asked us to calculate the distance PQ. The distance PQ, we shall use the cosine rule, which says that PQ squared is equals to PT squared plus TQ squared minus 2PT TQ cos 60. Now to get PQ squared, to get PQ, we shall get the square root of PQ squared and PT squared plus TQ squared minus 2PT multiplied by TQ multiplied by cos 60. Now computing that, we get that PQ is 88.8819 meters. Now part 2, we have been asked to calculate the bearing of P from Q. Now standing at P, how do you view Q? Now we know what is remaining to complete we know that the bearing of T from P is 30. Now you can see there's an angle between TPQ. If we get that angle, we just add to the 30 and we get the bearing of P. A tower is on bearing 0. Given that sine theta is 2/3 and theta is an acute angle, find tan theta, giving your answer in short form. To appreciate this question, we need to draw a right angle triangle, which I have drawn there. Now, when we have been told sine theta is 2/3, we know sine is the opposite side over the hypotenuse. Now it means that the opposite side is 2 units, hypotenuse is 3 units. Now, what about the adjacent side? The adjacent side, we shall take 3 units squared less 2 units squared, and then get the square root. So tan theta, which is the opposite over the adjacent side, will be 2 over chopping centers x, y, and z are such that y is 12 kilometers south of x and z is 15 kilometers from x. Z is on the bearing 330 from y. Calculate the bearing of z from x. Now, to understand this question better, we need to sketch a diagram of what we have been told. Now, I've sketched the diagram there. Now, from that diagram, the variables can be understood clearly. Now, we have been told to calculate the bearing of z from x. Now, the bearing of z from x, we shall use the sine rule. So, sine z will be equal to 12 kilometer multiplied by sine 30 over 15 kilometer. We get sine z to be 0.4. Now, 0.4 from tables is 23.58. Now, look at that bearing. Look at the diagram. The bearing of Z from X. The bearing of Z from X. If you look at that diagram clearly, you will see that we have an angle of 30 for our diagram. Now the angle we are finding is angle Z, the angle between X, the angle between ZX and ZY. That's the angle we are trying to find, which we got it to be 23.58. Now having found that angle, we add to the angle we know 30. Subtract it from 180. This gives us the bearing from of Z from X, which is 306.42 degrees. At angular plot ABC is such that AB is 36 meters, BC is 40 meters, and AC is 42 meters. Calculate 1. The area of the plot in square meters. Now, since we have been given all the sides, we shall use the hero's rule to calculate the area. The hero's rule, you remember, we get half the perimeter, which is S, and then subtract all the sides from S, then the product of everything, you get the square root. You can see I've computed down there, and I've gotten that area to be 662.0506 meters square. Now, part 2 of A, I've been asked to calculate the acute angle between the edges A, B, and BC. Now, since we have the area, we can use the sign where we say the area is equal to half base sine theta, and then you compute for sine theta, becomes 66.87. And then the last part, we have been told a water tap is installed inside the plot such that the tap is equidistant of the vertices A, B, and C. Calculate the distance of the tap from vertex A. Now, the distance of the tap from vertex A, it will be the distance AT. We shall use the sine rule to get. So we have that 6 meters sine 33.43 is equals to, all over sine 113.33 is equals to 21.5695. A rally car travels from point R to S. S is 128 km on bearing 060 degrees from R. The car then set off from S at 9:30 a.m. towards T at an average speed of 150 km per hour. It was expected at T at 11:30 a.m. After traveling for 1 hour and 20 minutes, it broke down at point P. The bearing of T and P from S is 300 degrees. Calculate the distance from R to P, the bearing of P from R and B. The repair took 10 minutes and the car set off to complete its journey to T. Find the speed at which the car must now move to reach T on time. Now the first part we have to calculate the distance from RP. The distance from RP, we can calculate it using the cosine rule. And you can see how I've computed them. So the distance RP is 175.4537 kilometer. Now the bearing of P from R, the bearing of P from R, just look at the diagram and see how you can calculate the bearing of P from R. You can see I've indicated. Now you can calculate that bearing use the sine rule. If we take 200 kilometers sine 60 over 175.4537 kilometer, we get 80.82 degrees. Now look at where P is. P is taking that arrow at R as the compass. You can see that in order to get that P, we have to get 316 less 80.82 and less 60, which becomes 339.81 degrees. So the bearing is 3.39 degrees. Now part B, how fast must the car travel? How fast must the car travel if it broke down and it was supposed to reach the destination T at 11:30 a.m. Now look, it started its journey at S at 9:30. To reach T at 11:30, it had to take 2 hours. Now it had traveled for 1.5 hours, and the repair took 20 minutes. So it means out of the 2 hours, it has only 30 minutes to cover the remaining journey and arrive at the destination at 11:30. Now we shall use those details to compute the speed it needs to travel. Now the remaining distance. So far the car has covered 200 kilometers out of the 300 kilometers intended to reach destination T. So it is remaining is 100 kilometers, and it has a time of 30 minutes. So speed is equal to distance over time. So 100 kilometers divided by 30 minutes, we get that the car should travel at 200 kilometers per hour in order to reach T at 11:30 a.m. as intended. Given that tan 75 is equal to 2 into the square root of 3, find without using tables tan 15 in the form of P plus Q into the square root of M, where P, Q, and M are integers. Now we can appreciate this question by having a right angle triangle. Now for a right angle triangle, we know that the remaining sides must add up to 90. Now if one side is 75 degrees, then it means the other will be 15. You can clearly see how I have indicated in that triangle. Now tan 75 degrees is gotten by taking the opposite side over the adjacent side. Now if tan 75 is equal to 2 plus the square root of 3, it means that the opposite side is 2 plus the square root of 3. Now the adjacent side must be 1. Now what will be tan 15? Tan 15, if you look at the diagram, tan 15, the opposite side will be the square root of 3. the adjacent side will be 2 into the square root of 3 plus 3. Now simplifying, get that tan 15 is 2 minus the square root of 3. A helicopter is stationed at an airport H on a bearing 60 degrees and 800 kilometers for another point P. For another airport P. A third airport J is on a bearing 140 degrees and 1,200 kilometers from H. A. Determine 1. The distance between PJ. Now I've sketched that diagram. Look at the PJ, where PJ is. Now that distance. Since we know the distance PH and HJ and the angle H, that distance can be calculated using the cosine rule, and we get it to be 1,553.5136 kilometers. Part 2 of A we have been asked the bearing of PJ, the bearing of P from J. Now you can see I've sketched that bearing that looks like a circle with a brown color and then a question mark. What is that bearing? To know that bearing, we must know the angle HJP. Now we can know that angle by using the the sine rule. So the angle is 30. The angle is 30. Now remember, from J up to where P has, look at that compass direction. We have already covered 180. So we just need to add on the degree of 50 minus 30.47. Adding that to 180, we find that the bearing is 289 degrees. Now part B, you have been told a jet flying at a speed of 1,035 kilometers per hour left J towards P. The helicopter at H also took off towards P at the same time. Find the speed at which the helicopter will fly as to arrive at P 12 minutes later than the jet. Now here we need to find the time that the jet arrives at P. So we know time is equal to distance over speed. So the jet will arrive at P after 1.5 hours. Now after knowing that, since they took the off at the same time, we must add how many minutes? We must add 12 minutes to that time the jet took, so that we are sure that the helicopter arrives at P exactly after 12 minutes. Now, after adding that time, on top of that, we realize that the helicopter has to take 1.7 hours to arrive at P. Now, we know the distance from P to H, and we have the time, so we can calculate the speed. So the speed that the helicopter must travel should be 470 kilometers per hour, so as to reach at P 12 minutes after the jet has arrived. Given that sine alpha is 1 all over the square root of 5, where alpha is an acute angle, find without using mathematical tables. A. cos alpha in the form of a into the square root of b, where a and b are rational numbers, and b tan 90 minus alpha. Now, for this question, we need to sketch a right angle triangle. You can see the one I've drawn there. Now, we know that cos alpha is given by adjacent side over the hypotenuse, and sine alpha is given by opposite side over the hypotenuse. So from our triangle, since we know sine alpha, then our hypotenuse is 5 in the the square root of 5, the square root of 5. That's our hypotenuse, and our opposite side is 1. Now the adjacent side, the figure below, at a triangular plot, the figure below, PQRS is a trapezium with SR parallel to PQ. SR is equals to 5 centimeter, RQ is 4 centimeter, QS is 8 centimeter, and PQ is 8 centimeter. Calculate A, the size of angle QSR, and B, the area of triangle PQS. Now, the size of angle QSR, we can compute it using the cosine rule, and we get it to be 24.15 degrees. And then part B, the area of triangle PQS, we can compute it using the sine, so it becomes a half base height sine Q, and the area is 16.364 centimeter square. At a triangular plot, ABC is such that the length of the side AB is 2/3 that of BC. The ratio of the length AB to AC is 4.9. The angle at B is obtuse. If the perimeter of the plot is that 8 meter, calculate A, the length of side BC, B, the area of the plot, and part 2 of B, the size of angle ABC. Now, we have been given all the variables of the triangle, at least the ratios. First, we equate side AB to be 2/3 and side BC to be 1. Now, if we have been given the ratio between AB and AC to be 4 to 9, we ask ourselves, if 1 is equivalent to 9, what about the 4? Oh, sorry, if how yes, we equate ourselves, we equate that we have been told AB and AC is equal to 49. So having said that AB is 2/3 and BC is 1, we ask ourselves, now if AB is 2/3 and is equal to that ratio of 4, what about AC? And when you compute that relationship, we find that AC is equals to 1.5. Now, having gotten all those variables and we know the perimeter, we can find now what each value is equivalent to. So we take the perimeter 38 plus 2 over 3x plus 1.5 x plus x. Then we get the value of x is uh, 12 centimeter, which means that BC is 12 centimeter, and then AC is 1.5 meter by 12 centimeter, and AB is 2 over 3 meter by 12 centimeter. Now BC, which have been asked, is 12 meters. Sorry for using the word centimeter. The units are in meters. If I've used in my talk that is centimeter, ignore it. It's meters. And if you see in any of my question, it is centimeter, ignore it is meters. Now, part B, you have been asked to calculate the area of the plot. Now, since we know all the sides of the plot, we can use the hero's rule to calculate the area, and the area is 38.25 meter squared. Part 2 of B, you have been asked to calculate the angle ABC. Angle ABC, we can calculate it using the cosine rule, and since the angle is obtuse, be sure that to subtract the angle you have gotten from 180 to get it. So the angle is 127 degrees. The figure below shows a quadrilateral ABC, in which AB is 8 centimeter, DC 12 centimeter, BAD 45 centimeter, CBD 9 centimeter, and BCD 30 centimeter. Find the length BD. Find the length BD, and B, find the size of angle ABD. Now the length BD can be computed using the sine 30. Take this because it's a right angle triangle there. Uh, you know the sine is the opposite side over the adjacent side. So sine 30 all over BD minus 12. BD is the opposite side, and then 12 is the hypotenuse. We get BD to be 6 centimeter. The size of angle ADB. The size of angle ADB, we calculate it using the sine rule, and that is angle D, which is 8 centimeter all over, 8 centimeter sine 45 all over 6 centimeter, and we get that angle to be 70.5 degrees. A boat at point X, 200 meter to the south of point Y. A boat at point X is 200 centimeters to the south of point Y. The boat sails from X to another point Z. Point Z is 200 on the bearing of 310 from X. Point X, Y, and Z are on the same horizontal plane. Calculate the bearing and the distance of Z from Y. Now I've sketched that diagram so that we understand the question. Now the bearing can just be computed from the diagram. We add 180 plus 165, and to get the bearing of Z from Y is 245 degrees. Now the angle or the distance, sorry, not the angle or the distance, just the distance. The distance ZY, you use the sine rule. It is 200 meters sine 50 over sine 65. So the distance is 169 meters. Part B, we have been asked that W is a point on the path of the boat nearest Y. Calculate the distance WY. Now look at the diagram where WY is. Now since we have been told it's the shortest distance, the shortest distance is always at 90 degrees. So we find a point at 9 degrees on zx joining y, which is w, and that point we can calculate it using the sine rule also. Not the sine rule, but the sine, the opposite side over the hypotenuse. So we take 200 meter times sine 50, we get that point to be 153. We are using the sine because it forms a right angle triangle. Now, the vertical, but see, we have been told a vertical tower stands at point Y. The angle of depression of the point X from the top of the tower is 6 degrees. Calculate the angle of elevation of the top of the tower from W. Now we know the distance from W. So what we shall use tan theta, the opposite side over the adjacent side. Yes, the adjacent side. So the adjacent side, the distance WY, and the height we have been told to ask to find, let's call it TY, is the opposite side, and we have now the angle of the figure below represents a quadrilateral piece of land ABCD divided into three triangular plots. The area BE and CD are 100 meters and 80 meters respectively. Angle AB is equal to 30, angle AC is equal to 45, and angle ACD is 100. Find to four significant figures the length AE, the length AD, the perimeter of the piece of the land, and lastly, the plots are to be fenced with 5 strands of barbed wire, leaving an entrance of 2.8 meters wide to each plot. The type of barbed wire to be used is sold in rolls of 480 meters. Calculate the number of rolls of barbed wire that must be bought to complete the fencing of the plots. So let's first calculate length AE. Length AE, we use the tan, the opposite side over the adjacent side, and we get it to be 57.735 meters. Now the length AD, we can calculate it using the cosine rule, and we find it to be 123.8345 meters. Now the perimeter of the land, we just add all those lengths from A to B, B to E, E to C, C to D, and back from A to D. And we get the perimeter is 177 meters. Now the plots are to be fenced. The perimeter we got above excluded length AC and AE. So we add that, and we find that the perimeter of the plots is 16 meters. Now subtract the gaps that have to be left. There are 3 because the plots are 3, and each gap is 2.8 meter. Subtract from the perimeter above, and then multiply by 5 because 5 strands of wire to be used. We find that the length of the wire has to be 3,073.72 meters. Now, if 480 meters is one roll, what about 3,073 3073.726 meters. It means we need 6.4 rolls. But since the rolls cannot be sold in fractions, we shall require complete 7 rolls to fence. In the figure below, angle A is equal to 62, angle B is equal to 41, BC is equal to 80, is equal to 8.4 centimeter, and CN is a bisector of ACB. Calculate the length of CN to 1 decimal place. Now here we can use the sine rule. Remember, if we have been told that CN is a bisector of ACB, it means that on each side that angle is bisected into 2. So knowing angle A, knowing angle B, it's easier to know angle C and then to know the angles formed by the bisector. Now using the sine rule, the length of CN is 5.6 centimeter to 1 decimal place. The angle of 1/8 radians at the center of the circle subtends an arc of length 23.4 centimeter. Find the radius of the circle. That is A, B, the area of the sector enclosed by the arc, and the radii. Now we know 0.0175 radian is equals to 1 degree. What about 1.8 radians? So 1.8 radians will be equal to 102.86 degrees. Now we know the circumference is angle theta over 360 multiplied by 2 pi r. So our theta is 102.86 degrees all over 360 multiplied by 2 multiplied by 22 over 7 multiplied by r. We compute and find our r is 13.0292 centimeters. Now part B, the area of a sector, we know it is angle theta over 360 multiplied by pi r squared. Now taking our angle 102.86 over 360 multiplied by 22 over 7 multiplied by the radius we have just gotten 13 centimeter, we get our area to be 152.4481 centimeter squared. In the figure below, AB is equal to 8 centimeter, AC is equal to 6 centimeter, AD is equal to 7 centimeter, CD is equal to 2.82 centimeter, and angle CAB is 50 centimeter. Calculate to 2 decimal places A, the length BC, B, the size of angle ABC, and C, the size of angle CAD, and D, the area of triangle ACD. So BC, we can calculate it using the cosine rule, and we get it to be 6.19 centimeter to 2 decimal places as we have been instructed. And then angle ABC, we can calculate it using the sine rule, and we get it to be 47.95 degrees. The size of angle CAD, we can calculate it using the sine rule still, and we get it to be 23.51. Then the area of triangle ACD, since we have all the measurement of that area, all the size we are known, we can calculate it using the hero's rule, and we find it to be 8.37 centimeter square. In the figure below, PQ is parallel to RS. The lines PS and RQ intersect at T. RQ is 10 centimeter, T to TQ is 3 to 2. Angle PQT is equals to 40 degrees and angle RTS is equals to 80 degrees. Find the length RT. That's A. The length RT can be found by taking just using the ratio because it's 3 to 2. So RT is 3 over 5 multiplied by 10, which is 6 centimeters. Part 1 of B says the perpendicular distance between PQ and RS. The perpendicular distance, since it forms a right angle triangle, we can use the sine, that is the opposite side of a hypotenuse. So we have h sine 40 plus h sine 40 because we have two similar triangles on both sides of the parallel line, and they have a common height. So they don't have a common height, they have heights that complete each other, or they meet to form a single line. And we have that height to be 6.4 if we use the sine. Part B, we have been asked the length of TS. The length of TS, we can calculate it using the sine rule, and we get it to be 4.5. And then part C, using the cosine rule, find the length of RS correct to 2 decimal places. Now, using the sine rule, RS will be 6 squared plus 4.5 squared minus 2 multiplied by 6 multiplied by 4.54 multiplied by cos 80. So sorry for what I've written as 4.54. That's a mistake. It should be 4.45. So if you compute that, we get 6.8 centimeter. But you have been asked, calculate correct to 1 decimal place the area of triangle RST. The area of triangle RST, we use the sine half base height times sine 40, and the area is 13.1 centimeter squared. A triangle ABC is such that AB is equals to 5 centimeter, BC is equals to 6 centimeter, and AC is equals to 7 centimeter. A. Calculate the size of angle ACB. Correct 2 decimal places. Angle ACB, since we know all the dimensions of the triangle, we can compute the area both using the hero's rule and the sine, so that we get sine C, and we get that angle to be 44.42 degrees. Part B, you have been told a perpendicular drawn to meet A meets BC, sorry, a perpendicular drawn from A meets BC at N. Calculate the length AN to 1 decimal place. You can see I've dropped that perpendicular using a dotted red line. Now, what is the length? The length of that perpendicular, you can calculate it using the sine, because now we have a right angle triangle. And if you compute, you find it is 4.9 centimeter. The area sector of a circle radius 2.1 centimeter is 2.31 centimeter. The arc of the sector subtends an angle at the center of the circle. Find the value of theta in radians correct to 2 decimal places. So we have the area, and we know area is angle theta pi r squared. So substituting the values we know, we remain with the theta, and compute for theta, we get that theta is 60 degrees. Now we know 1 degree is equals to 0.0175 radians.